All right, we're going to do some empirical rule problems that are a little more advanced than problems we've been doing. We're using the empirical rule, which is the 68, 95, 99.7 rule. So we have the same lid scenario from the previous problem. I'm just going to write down what the situation was. We had the lids where the mean, and remember that symbol means mu is mean, was 3.98, and the standard deviation was 0.02, and it was a normal distribution of the diameter of the lids. So I'm just going to draw the sketch of what the normal distribution looks like. Okay, so I just drew my normal distribution, I labeled the mean in the middle, and then I counted, I added 0.02 in each direction until I got 3 standard deviations above the mean and 3 standard deviations below the mean. So A is what percent of lids have diameters between 4 and 4.02. So then I'm just going to mark that on my graph, 4 and 4.02. So I want to find this shaded area just between those two measurements. Okay, so we still are using the 68, 95, 99.7 rule, the empirical rule. So what I'm going to do is I know that just from here to here, 1 standard deviation above and below the mean, that's 68%. So I'm going to mark that up here, 68%. And then if I go 2 standard deviations, so from here all the way to here, that's 95%. I'll mark it down here, 95%. So if I want, let's pretend that we actually want both of these shaded sections, even though we just want one. We want that one to the right, but I'm going to shade this section to the left also. If we want those 2 shaded sections, if we want this section and this section, that area, that would be 95% minus that 68% in the middle. So 95% is all the way from here to here. But if we wanted to take away this 68% in the middle, I don't want that. That'll give me those 2 shaded regions. So that leaves me with 27%. But what I really wanted was just from 4 to 4.02. So I really just wanted this section. I didn't want the other one. So then I'm just going to divide what I just did by 2, the 27%, divide by 2, and then I'll get 13.5%. All right, let's look at B. Estimate the percent of lids that have diameters less than 3.95 inches. So I'm going to mark where 3.95 inches is on my number line. I have 3.94. It's a little above that. So I'm just going to put a mark here. And it says we want less than, so I want this area. So this isn't exactly 1, 2, or 3 standard deviations below the mean. It's between 1 and 2 standard deviations below the mean. So I'm going to use what I know from the empirical rule to estimate what this area would be. So I'm going to mark that if it was 3.94, everything that way I want to figure out what that percent is. So let's start with that. So 3.94 is 2 standard deviations below the mean. If we're between 2 standard deviations below the mean and 2 standard deviations above the mean, that's 95% of the values. So outside of that would add up to 5%. There's 2.5% this way and 2.5% this way. Because when we add that up, it'll all add up to 100%. 2.5 plus 95 plus another 2.5, that'll all add up to 100%. Then I'm going to go to 3.96. And I'm going to figure out what percent is less than 3.96. And then 3.95 is going to be somewhere between those 2%. So less than 3.96. 3.96 is 1 standard deviation below the mean. So if we're between 1 standard deviation below the mean and 1 standard deviation above the mean, that's 68% of the data is between those, between 3.96 and 4. So outside of that and the other 2 tails would be 100% minus that middle 68% area, which is 32%. If we divide that by 2, we get 16% on each side. So 16% is above 4, and 16% is less than 3.96. So now what I have is 16% is everything less than 3.96. And then 2.5% is everything less than 3.94. I want everything less than 3.95, which is between those two. So we're just going to estimate any number that you estimate between 2.5 and 16 is fine for now. So I'm estimating about 7%. All right, let's look at C. Lids with diameters greater than 4.04 inches will be too large for the restaurant's large drink cups. What percent of the lids will be too large? So we want the percent that's greater than 4.04. Okay, so I just erased the other stuff. I'm going to mark 4.04, and we want what percent will be too large, which will be greater than 4.04. We want that tail area. So 4.04 is 1, 2, 3 standard deviations above the mean. Let's mark 3 standard deviations below to 3 standard deviations above the mean. That was 99.7% of the data according to the empirical rule. So if we want outside of that, we want what's left over. So if I do 100% minus 99.7%, I get 0.3%. But that's for both areas. So if we divide that by 2, 0.3%, then we'll get that broken up in 2 and get both little tail areas. So that's 0.15%. So 0.15% is here, and 0.15% is less than 3.92. So my answer is just going to be 0.15%. Part D has to do with the previous problem. So it says, suppose the lid supplier ships 1,500 lids to the restaurant. How many of the lids are expected to be too large? So we're using that 0.15% are going to be too large. So we want 0.15% of 1,500. So what we do is convert it to a decimal. So 0.15% is 0.0015. So I'm just moving the decimal place over twice, times 1,500. That'll give me 15% of 1,500. And that works out to be 2.25. But we want number of lids, so I'm just going to round that to about 2. About 2 lids would be the number out of those 1,500 that are expected to be too large.